Hola, physics friends, and welcome to 15.2, part 2. I've entitled it Extra Practice Problems. What I'm going to do, I'm going to go through 4 more problems. These open and closed tube problems, in my opinion, are the most difficult conceptual thing that we face in all of physics. So I wanted to just give a second round to show people what I do, how I solve this. Maybe you took a stab at them, you saw my first video, and it's like, okay, I see him do it, and then when you get to the questions, you're like, I honestly have no idea. Like, that just, it made sense when I watched him, but now when I'm putting pencil to paper, I have no idea. I'm going to give you a second round, me solving some problems, and hopefully you can pick up on some of the techniques and tips that I use to go through. So we're going to rip through these. There's 4 questions, and I'm going to go through them just so you have an idea of how I solve some of these problems. Let's get started. All right, number 1, it says give 2 frequencies which will resonate in a closed tube that has half a meter length. So first of all, when you've got a closed tube, I'm gonna draw a tube and I'm gonna close it off, and I'm gonna draw a wave in there. When you have a closed tube, remember that you have to have a node on the closed end and an antinode on the open end. So here's the first one. The first frequency is a quarter of a wavelength. So, and this distance, it said in the problem, is 0.5 meters. So what I'm going to do, I'm going to use this this is 1/4 of a wavelength. So 1/4 of a wavelength is equal to 0.50 meters. So that means that one wavelength is equal to 2 meters. So then I can use velocity is equal to wavelength times frequency, the speed of sound. The wavelength we just found was 2, and now I can figure out what frequency that is. So I take 343 and I divide by 2, and you get 170 hertz. So there's frequency number 1 that will work in there. The second frequency is 3/4 of a wavelength. So I have my node and then this. So 3/4 of a wavelength is equal to 0.50 meters. So that means that a wavelength, you multiply by 4 and then divide by 3, is 0.67. So when I use velocity is equal to wavelength times frequency, my velocity is 343. My wavelength is 0.67, and now I can find my frequency f. So that frequency, second one, turns out to be 510 hertz. Like that. Here's the key. Knowing that when you have a closed, it starts at 1/4, 3/4. The next one, if I was going to do another one, would be 5/4. Like that. And so on, and I would follow that same idea. Let's do another problem. Give 2 frequencies which will resonate in an open tube of length 0.5 meters. So I've got that same idea where I've got a tube and it's open on both ends. So the first wave, which is going to work, is half a wavelength. Or I think that I liked to write it when I was explaining all of this as 2/4 of a wavelength. And then this distance right here is 0.50 meters. So if 2/4 of a wavelength equals 0.5 meters, that means a wavelength, you multiply that by 2, is equal to 1 meter. So then, using velocity is equal to wavelength times frequency, speed of sound is 343. My wavelength is 1. And now my frequency, 343 divided by 1, is 343 hertz. So there's my first frequency. My next frequency is going to be similar, except I'm going to have, again, we have to have antinodes on both of these. My next one is 4/4. So 4/4 of a wavelength equals 0.50 meters, which means that the wavelength is actually equal to 0.50 meters. So when I go velocity is equal to wavelength times frequency, my velocity is 343. My wavelength is 0.5. My frequency is unknown. So I take 343 times 2, and that's 686. So frequency number 2 is 686 hertz. What if the question says not find the frequency? What if the question now says find the length of the tube? So what I'm going to, instead of starting with me drawing a picture of the tube, now what I'm going to do is I'm going to draw a picture of the wave. Right? I've got a wave, and the frequency is 440. So what I'm going to do is I'm going to go velocity is equal to wavelength times frequency. My velocity is 343, and now my frequency is 440. So I can figure out what the wavelength is. So it's 343 divided by 440, and that's 0.78 meters. So what that means is this distance from peak to peak, or trough to trough, is 0.78 meters. So when I have an open tube, remember, has an antinode on each end. So here's an antinode, and here's an antinode. So here's the shortest open tube, which will work. And this is half the wavelength. So I'm going to kind of run this equation in reverse from what I did last question. So half my wavelength, half my wavelength is equal to 0.78 meters. So that means, half my wavelength, half my tube, let me say it this way. My tube length equals half the wavelength. Right? So my tube length is half the wavelength. And since we know a wavelength is 0.78, I'm making this more complicated than it needs to be. You just know that this tube is half this distance right here. So just 0.78 divided by 2. But I want to kind of show you. So my tube length number 1, half of 0.78 is 0.39. My next tube length, I have to go from antinode. So here's an antinode. And now I'm not going to go to the first one, but now I'm going to go to the next one. So here's my tube length. And then this tube length, from here to here, is 1 4/4 wavelength. So the tube length is the wavelength, right? So the tube length is equal to 4/4 of the wavelength, or 1 times the wavelength. So the tube length in this case, straight up, 0.78 meters. Tube length number 2, 0.78 meters. One more. Give the two shortest closed tube lengths. So again, I'm going to start with my wave. And I want to figure out what the wavelength is. Like, what's the length of one of these waves? So what I'm going to do, I'm going to go velocity is equal to wavelength times frequency. My velocity is 343. Don't know my wavelength, but my frequency is 525. So when I take 343 divided by 525, I get a wavelength of 0.653. So this distance right here, 0.653. So when I do a closed tube, remember that a closed tube has a node on one side and an antinode on the other. So I'm going to start with a node. And here's a node. So here's where my closed end is going to be. And my antinode is right here. this is 1/4 of a wavelength. So my tube, that tube length again, is 1/4 of a wavelength. And since we already know the wavelength, 0.653, you just take that number divided by 4, and you end up with 0.163 meters. That's tube length number 1. The shortest one. The shortest one's 1/4 of a wavelength. My next tube, again, I have to start, I'll do it in blue. I have to start on an antinode, and the antinodes are right here, and I can start on any one of these that I want. And then I go, not to the first, I started a node, I'm sorry, these are nodes. I misspoke. But then I don't go to the first antinode, I go to the next one, which is right here. And this isn't 1/4 of a wavelength. This right here, this is 3/4 of a wavelength. So the tube length is 3/4 of a wavelength. And since we know the wavelength, again, is 0.653, you take 3/4 times 0.653. So that tube length, second one, that will work, 0.490 meters. All of this is hinging around the fact that all these questions, I kind of am flexing the same idea that when you have an open tube, they go 2/4, 4/4, 6/4, 8/4, 10/4, and so on. If you have a closed tube, they start at 1/4 of a wavelength, 3/4 of a wavelength, 5/4 of a wavelength, and so on. But I wanted to, these questions are hard, and they are not easy. And I think that the more times you see someone attack them, maybe the more ideas that you get on how to solve a problem like this. And thanks for watching. These are tough. Stick in there. The more times you try them, it's just a process that hopefully through seeing them, trying a bunch of them, it all of a sudden clicks, and that's our goal.